Today I'd like to discuss lunar and solar eclipses. Okay, whenever you start talking about eclipses, what these are astronomical alignments which block out either one body or the other. The body that is blocked out is how the eclipse is actually named. So in the case of a solar eclipse, this is whenever the moon passes between the earth and the sun and it blocks out either all or a portion of the sun. And a lunar eclipse is whenever the moon actually falls into the earth's shadow. It's the sun, earth, and then moon, and then the shadow is cast upon the surface of the actual moon. So that's the primary difference between lunar and solar eclipses. Okay, so whenever you start looking at these, one of the things that you have to understand is you have to kind of see, okay, what is the celestial setup? So whenever you have a solar eclipse, as is depicted in the top image, what you have there is the moon is in new moon phase. And then whenever you have a lunar eclipse, the moon must be in a full moon phase. So understanding the position of the earth, moon, and sun is essential to understanding eclipses. Okay, whenever we start looking at the different types of eclipses, we're going to start with lunar eclipses. Now, whenever you start talking about these, most people think, well, there's just a lunar eclipse, there's just a solar eclipse, and that's it. Well, what you can actually see from this image is there's different types of lunar eclipses as there is different types of solar eclipses. Okay, so whenever you start talking about shadows, you have to understand that we do have two types of shadows. What you have is you have the umbra, which is this dark portion right through here, and then the penumbra, which is the light portion of the shadow. So it's basically a game of angles that you're looking at there. Well, whenever the moon is passing through the penumbra, you have what is called a penumbral lunar eclipse. And then, of course, whenever you start getting where it's half into the umbra and half into the penumbra, then what you have is a partial lunar eclipse. And whenever the moon is actually into the umbra, it is a total lunar eclipse. So there's the three types of lunar eclipses that you can see. Now, one of the big questions is why don't we have an eclipse every full and new moon phase? Well, whenever you start talking about this, it's kind of tough to really even explain without, of course, the help of imagery here. What you can see, though, is the orbital plane of the moon is 5 degrees, so off of the plane of the ecliptic. So in other words, this right here is the orbital path of the Earth, and then there is a 5-degree tilt. And because of that, the moon is sometimes higher than the sun and sometimes lower than the sun. And because of that, you're not going to get that perfect vertical alignment. Now, whenever the moon is located where those two planes intersect, that plane intersection is called the node, and that's what I'm pointing to right here, is that region called the node. So if you have it in full or new moon phase and it's on the node, then you are going to get an eclipse to occur. Okay, so right here, this diagram is showing where the moon actually passes through the umbra. And another one of the major questions that they have is why does the moon turn this reddish color instead of going completely black? Well, what ends up happening here is it's something called refraction. As sunlight passes through the Earth's atmosphere, the wavelengths are stretched out, of course, until the red portion of the spectrum. And then that image is actually projected onto the actual moon. So what ends up happening is sunlight is basically being bent around by the Earth's atmosphere, and then the light is hitting the moon's surface. And so what you end up getting is you end up getting this blood moon appearance. Okay, so whenever you start looking at this, the total phase of a lunar eclipse is interesting because it's like beautifully precise with everything that goes on. Okay, so whenever you start looking at this, and there's several different alignments that we can get, but how we perceive the moon is really based on the interactions of our atmosphere, where the sun is in relation to the moon. And then it can actually start to take a range of colors from like darks, dark browns to reds to bright orange and yellows. Okay, but what really also may have an influence on this is on how much dust and clouds are present in the atmosphere. So what you're doing is you're basically having an interaction of the atmosphere with light and then with objects in our atmosphere and light. And so that's kind of influencing what we see. Okay, so whenever you start talking about solar eclipses, a solar eclipse is, of course, whenever we start blocking out the surface of the sun. This can only occur at a new moon phase whenever it passes between the Earth and the sun. So whenever you start looking at this, where you are located on Earth determines what you're going to see. Are you going to see a total solar eclipse, or are you going to see a partial solar eclipse? But what it is it's based off of that shadow that we talked about earlier. Okay, so whenever you start looking at this, now we're going to, of course, go back into the Umbra and the Penumbra. Okay, so whenever you start looking at this, and here's what's going to occur. If you are in this region right here, if you are in the shadow of the Umbra, you are going to go into total darkness. Whereas if you're in the Penumbra, you're not going to go into total darkness. So what you actually observe is dependent, does the umbral pass, or does the umbral shadow pass at your location? That will determine if you are completely blocked out or if you're only partially blocked out. Okay, just like with lunar eclipses, we have different types of solar eclipses. As you can see depicted on the one on the left there, you have a partial eclipse. And then you have something in the middle there called an annular eclipse. And then last but not least, you have a total eclipse. Now, one of the primary reasons that we have an annular eclipse and a total eclipse is because it is due to the actual distance to the moon. Of course, if the moon is farther away, so it's at apogee, what you're going to get is you're going to get an annular eclipse. Whereas if it's at perigee, you're going to get a total eclipse. So that's the primary difference between observing an annular eclipse and a total eclipse. And what you're going to look for is on an annular eclipse, you can still see the surface of the sun on the outside. Whereas on a total eclipse, all you can see is that bright flash. And that bright flash is called the corona. Okay, so here's what you basically are looking for and what I just described to you, the diagram to help you. Okay, notice right here that the moon is in new moon phase. It's passed directly between the sun and the earth, but it is much closer than this position where it's in a new moon phase. Okay, so because of the apogee and perigee, you're going to observe different things. And then of course right here, you can see if it's not completely on the node, what you're going to get is you're going to get a partial solar eclipse. Okay, this is what I mean right there. If you are located in the umbral region, what you'll have is you'll go to complete darkness. And then of course everywhere else you're kind of in the penumbra, and with that you're going to see different things. This area though will experience regions of complete darkness. Okay, what you're seeing right here is you are seeing a total solar eclipse. So of course the moon at this was in a new moon phase, and it's at perigee. As you can see right here at the bottom though, what you're seeing is a transition, I don't have an animation for this, of what is called an annular eclipse. This is when the moon is in new moon phase, but at apogee. Here you can see what is called a partial solar eclipse. This is because the moon is not directly on the node, but what you're doing is you're passing through the penumbral region of the actual shadow. Okay, so one of the big questions is why are eclipses so rare? Well, what you need is you need that perfect astronomical alignment. As I mentioned earlier, there's this thing called the node. Well, whenever you get that plane of the ecliptic, if you're looking right here, you notice that the plane of the ecliptic, whenever they cross, what's going to end up happening is you've got it perfectly aligned right in the middle. If you don't have perfect alignment, you're not going to get a total eclipse. You're only going to get a partial eclipse. Okay, so what this ends up doing is because of the revolution of the moon and its 5-degree orbital tilt, you don't have perfect astronomical alignments. And that's why we only experience anywhere from 4 to 7 eclipses a year. Now, with this, doesn't always mean that you're going to observe an eclipse. Again, it's based on where you're located latitudinally and depend upon where the umbra is actually reaching the Earth's surface. So Whenever we start looking at this, you've got to have perfect alignment, and the moon must be in the correct phase, as well as be either at apogee or perigee, and then on the node, and that'll determine which type of actual eclipse you're going to get. Okay, so to kind of reiterate, if the moon's orbit were exactly aligned with the ecliptic, we would see a solar eclipse every new moon, a lunar eclipse every full moon, but we don't see it. It's because of the moon's orbital tilt of 5 degrees from the ecliptic, and where the moon's orbit crosses the ecliptic defines the line of nodes. Eclipses can only occur when lined up exactly right there, and this diagram shows it. Okay, so this right here will basically conclude our actual lecture on lunar and solar eclipses. It's relatively simple. With the next unit, or with the next topic, we're going to be talking about how we've developed the science of astronomy and looking at observations of the actual sky.